Take this one. So we are going to talk about these two: network access control list. The other one is security group. We have little bit idea about security group. We did some work on security group. So I'm trying to give you the more information on this one. See, they provide security. One provides security for your EC2 instance. If I say security group, so when we create EC2 instance, every instance must be associated with a security group. It provides a kind of firewall for the EC2 instances, right? The other one is network access control list. This also provides a kind of firewall, but at subnet level. So one is at subnet level, the other one is at instance level. In one subnet, we might be having hundreds of instances. So they both provide a kind of firewall. One is for subnet, other one is for security group. Sorry, in EC2 instance. See this one. Security group, right? They are a kind of virtual firewall for EC2. So please keep that in mind. Security group is for EC2 instance, which controls the inbound as well as outbound traffic. So security group acts like a virtual firewall for your EC2 instance. So let me give you a theory first, then we'll get into the practicals. So network access control list, right? Sometimes we call it as NACL or access control list. It acts like a virtual firewall at subnet level. So one is at instance level, the other one is at subnet level. So there are chances you can expect a question: how security group is different from network access control list? To answer that, we need to discuss more on this one. Let's see a pictorial representation where they are aligned in the, that is your routing table. Correct? We have one subnet. Let's say we have one subnet, couple of EC2 instances in that subnet. Generally, this is how your routing table looks like. If you're using default route table or main route table, by default we have only one route, the topmost, correct? The local, and the second one is attached with internet gateway that we modify generally. So that is your current route table. Generally, the traffic comes outside, from outside. So first it will come to the route table. So is there any route to the route table? Yes, from internet anyone can reach your route table. If you see the second rule here, anyone, the destination is anyone, can reach this routing table with help of the internet gateway. So now there is a route. Yes, we can try to reach the subnet. From subnet we can reach our EC2 instance. Like when you say SSH, correct? This is what happens internally. See that? Before it reaches your subnet, there is a network access control list. Remember, this is at subnet level. If that allows your traffic, you will enter in. If it denies, your packets are dropped. So there is one network access control list on top of every subnet. If that is allowing, see, then security group comes into picture. Security group is on top of your EC2 instance. Can you see this one? NACL is at subnet. Security group is at EC2 instance. Take this one first. So at least one security group is mandatory. Without creating a security group, you cannot launch EC2 instance. So minimum one security group is mandatory for us. It's mandatory. So we can have maximum 5 security groups. So if it can increase, there is elastic network interface attached to your EC2 instance. If I attach one more ENI, I can add 5 more security groups. So it doesn't mean the maximum is 5. If there is one elastic network interface attached, then 5 security groups. If you want 5 more, attach one more ENI and you can put 5 more LC. We can add 5 more security groups. So it's going to manage your inbound and outbound traffic. But there is some trick here. See, there is a rule saying I accept this. I accept this traffic. By default, that can go out. So what I mean to say is, security group controls only inbound. It doesn't control outbound. So probably I need to take this off. So this one, don't take this one. It manages inbound. So whatever it accepts, right, the same traffic can go out. Correct. So I can say I will stop this incoming request. I cannot say I will stop this outgoing request. If something is coming in, it can go out. So I need to change that slide. So it manages inbound traffic actually. So so I can only control what is coming in. I cannot control what is going out. So whenever we change the security group rule, the effect takes on fly immediately, almost immediately. If I add a rule, within seconds, it takes effect. Let's say I don't want to accept, I want to block a particular IP address. Add a rule, block it. Correct? For example, it takes immediately. The effect takes immediately. No need to restart, no need to do anything there. Whenever we change the security group, the effect is immediate. It happens dynamically. So it says security groups are stateful. We will see why we call it as a stateful after discussing network access control list. So every instance must have one, minimum one, maximum can be anything. But if an instance is having only one ENI, it can have max 5 security groups. So first let's demo. So how to use these security groups. Then we'll talk about similar details for NACL, and we'll also do a demo on network access control list. So get into your Amazon console. Let's open EC2. So let's open running instances. So this we have one instance here. If you see the description below, there is a security group for that. Minimum one, correct? And I can see the rules here itself by clicking this particular link. What it says. It allows SSH from my machine, only from my machine. What's the other one? It allows HTTP traffic from everybody. Let me open this security group. See this one. This is the inbound rule, correct? The incoming rule. Who can come inside or who can access my EC2 instance? Only I can ping using SSH. That's rule number one. The other one is anyone can send HTTP request because the source is 000 slash something like that. So can we add more rules? Definitely yes. I can go and add more rules on top of it. So what I mean to say is, they are saying Security groups are stateful. See this outbound rule. We cannot control outbound rule. See, let's say if I am accepting HTTP protocol, HTTP request, it automatically goes out. I cannot stop it. If I am accepting SSH, then it also mean it can go out. So if I am accepting inbound request, the same can go out. There is no way to control that one. There is no way to control that. Let's say I accept HTTP and I won't respond. That option is not there. Even if I delete it, for example, it won't give you any effect. If you're accepting HTTP, the client will get a response. So that is your network access control list. Security group. Can we add more than one security group for a EC2 instance? Yes, up to 5. Okay, next one is, we already seen all those things, correct, for security group. The next one is network access control list. Network access control list. Yeah, I'll show you. So when you launch when you launch EC2 instance, there you have an option to add more ENIs. So by default, it comes with one network interface. We can add more, and we can add more security groups for that one. So NACL is at subnet level. Did I create NACL in the previous demos? No. Even if I don't create any NACL, see the first point. Your VPC automatically comes with a modifiable default network access control list. Even if you don't explicitly do that, correct, your VPC automatically comes with one NACL. By default, what it does, it allows all inbound and all outbound traffic. See, even if I don't create a NACL, when you create your VPC and subnets, this comes by default. By default. So what is a default NACL? What are the rules in the default NACL? It accepts all inbound. It allows all outbound traffic. On top of it, we can go on control. We can put restrictions. The subnet can have only one network access control list at a time. In case of security group, EC2 can have more than one security group at a time. But when it comes to NACL, your subnet can be associated with only one. But it can have lots of rules. Rules can be more, but the NACL should be one. So NACL supports a separate rule for inbound, separate rule for outbound. In case of security group, there is no separate, even though they have an option to provide rule for outbound, that never comes into effect. That doesn't work. In case of security group, we can control what is coming in. Getting my point? We can control what is coming in, but there is no way to control what is going out. If I am accepting HTTP, HTTP response will go out. I cannot stop it. But in case of NACL, we can control inbound as well as we can control outbound. I can say allow this, I can say deny this. But in security group, there is no option to say allow, deny. If you add a rule saying allow, it's allowed. And there is no option saying deny. If I want to block a particular IP address, I cannot do that using security group. But can I block IP address using NACL? Definitely yes. Because it supports both inbound, outbound, allow, deny. There I said security group is stateful. Here I am saying network access control list is stateless. So let's discuss that soon. So this even I faced interview question on this. Is NACL stateless or stateful? Is security group stateless or stateful? And they ask you using security group, can I block IP address? No. But can I block IP address using NACL? Yes. Those differences we must be aware of. So what do I mean saying stateful? What do I mean saying stateless? Take that point, please. Security group is stateless. Sorry, stateful. Security group is stateful. That is, see, there is an inbound rule in a security group. That rule is remembered even when the traffic goes out. That's the meaning of stateful. See, there is a traffic coming in. Security group will check the traffic. It verifies whether this is allowed or not. If it is allowed, correct, it will remember the same while the traffic goes out. That's the reason we are calling it as a stateful. That is, if there is any traffic which has inbound access, if there is any traffic which has inbound access, the same is remembered. The same is remembered when this traffic goes out. The same is remembered when this traffic goes out. That's the reason we are calling it as a stateful. What about NACL? It is stateless. Why? It remembers the traffic when it comes in. It won't remember the traffic when it goes out. So while going out, it gets an outbound route. Next point. NACL is stateless. I don't know whether this problem is only with Dhananjay or everyone. All of you, can you hear me? Online guys.
Yes, sir.
Now clear. Okay, fine. Okay, so I'm talking about NACL. It is stateless. Okay, that is NACL is stateless. That is, if there is a rule which accepts inbound traffic, if there is a rule, sorry, what I said? If there is a rule which accepts inbound traffic, which accepts inbound traffic, this rule is not remembered. This rule is not remembered when this traffic goes out. This rule is not remembered when this traffic goes out. Goes out. To allow or deny. To allow or deny this outbound traffic. To allow or deny this outbound traffic is decided by outbound rule. See, in this case, what is accepted? Decided by inbound rule. What can go out is decided by outbound rule. It is stateless. Whatever coming in, that is not remembered while going out. Correct? So whatever comes in, it comes in, the rule is forgotten. And while the traffic goes out, there is outbound rule. It depends on that outbound rule. That's the reason we're calling it as a stateless. But in case of security group, whatever comes in, that rule is remembered even while going out. That's the reason we're calling that as a stateful. So this is your default network access control list. What it does now? See this one. Inbound, one is incoming, correct? Rule number 100. I'll talk about the rule number soon. All traffic, all protocols, all port range, source from anywhere, it is allowed. It is allowed. So forget about the second rule. Come to outbound rules. See this one. Again, rule number 100. All traffic, all protocols, all port range from anywhere, it is allowed. This is default. That's what I said. So default access control list accepts all protocols and even sends out, accepts all traffic, sends out all traffic. That is a default. So on top of it, let's say there is a suspicious IP address. I want to block him. Can I put a rule on this? Yes, I can add one more rule specifying that IP address, and I can say deny. In security group, we don't have option to allow deny, correct? There, if I add a rule, then it is allowed. I cannot say deny this. But in network access control list, we have an option to deny plus allow. So if you want, you can take this table. That's your default ACL. So when we create a VPC and subnet, that's the one you get by default. So let's see the demo. What is NACL, how to control, how to change. Okay. So where we can find NACLs. So NACLs is at subnet level. The subnet is at VPC, correct? So go to VPC dashboard. Sorry. So can you see that VPC subnet, below that network access control list? Right now we have two network ACLs. One is for default VPC, the other one is for our DevOps demo VPC. Let's see that rules, inbound rules. Rule number 100, this is what I have shown in the slide. Inbound rule number 100. All traffic, all protocols, all port allow. See outbound rules. It's also the same. It's also the same. So can we change them? Yes. Let me say edit. Add another rule. See, they are suggesting you, we have 100. What's the next rule number they are suggesting? 200. Let me give you explanation for that one. Let me say rule number 1. All traffic. I want all traffic. All traffic. All protocol source. 0.0/0. Allow, deny. Let me say deny. Save it. See this one. How it work now? One rule says allow, other rule says deny, correct? So how this work now? So how the rules are evaluated is, it starts from the lowest number. So what is the lowest number here? 1. Let's say there is incoming traffic coming to my subnet. So it evaluates the rules in your network access control list. What's the first rule there? All traffic, all protocol, all port range from anywhere. What it does? Deny. So now my request is dropped, blocked. It will not check the second one. So it will try to match the rules from lowest number to highest number. Whenever there is a match, that takes effect. That takes effect. So let me repeat the same process again. So there is a HTTP request coming from some IP address. So which rule it evaluates first? Smallest rule number it evaluates first. Okay. Rule number 1, all traffic. HTTP comes under all traffic. All protocol, all port, source from anywhere. It's all matching, right? What it says? Deny. What happens to my request? It is dropped. It is blocked. Even though next rule says allow, before going to the next rule, the first rule itself says deny it. Once the condition is matching, right, it takes the action in that condition. It says deny, deny it. No need to evaluate the other rules there. So that is how access control list work. Let's take this one. Take this and let's understand how NACL work. Even rule numbers are very important for us. See, automatically rule number 1 is coming to the top. The evaluation happens from top to bottom, if you don't remember that. So first it checks rule number 1. If the condition is matching, if it allows, it allows. If it denies, it denies. That's all. If condition is not matching, then it comes to the second rule. Or shall I? One second. Let me do one thing here. Let me give you. Let this makes more sense. This is a question again. How to specify a single IP slash 32? See, your IP address slash 32. I cannot just put IP address there. It doesn't work. The IP address slash 32. That's also your interview question. They ask you how to block a particular IP address. IP address slash 32. So slash 32 is to specify your IP address. That's a convention. So somewhere while creating VPC we use slash 16. While creating subnets we used slash 24. Likewise, if you want to specify a particular IP, then it is slash 32. Yes, yes, correct. Obviously, there might be a limit, but we can increase that one. We can also use a IP address range. Let's say I want to block all IBM network. I can put that range, block it. Not only one IP, I can put a range also there. So how to understand this one? Let's take two use cases. Let's say there is a traffic coming from this particular IP, 55444466. So which rule is evaluated first? Rule number one. What it says? Deny. So if a request is coming from this source, from this IP, that request is denied. We are blocking them. Let's say there are some attackers attacking your systems. Yeah, they are suspicious. You can block. So take this point. See, if a traffic is coming from 55444466, if a traffic is coming from 55.44.44.66, it is denied. It is denied. Next one. See, if I say the traffic is coming from other IP, let's say the IP address is 11111111. Is it matching your first rule? No. What happens now? It'll evaluate the next rule. So what is that doing? It allows. So except this particular IP address here, the other IP addresses are allowed. So except this one, the remaining traffic is allowed. So take these points. The evaluation of rules happens from smallest rule number happens from the evaluation of rules happens from smallest rule number to highest rule number. It happens in ascending order, I can say. So the evaluation of rules happens in ascending order, like 1, 2, 3, 4 kind of. So we can allow, we can deny. In case of security group, there is no concept saying allow, deny. We can control inbound as well as we can control outbound. We can control outbound. But in case of security group, that's not possible. So how to name rule numbers? So according to Amazon, what they say is give rule numbers like hundreds, like 100, 200, 300, kind of. The reason is after some time you have more rules, you can put between 100 and 200, or you can put between 1 and 100, kind of. If I say 1, 2, 3, if I want to put rule between 1 and 2, it's not possible. Take that point. The best practice, the best practice to give a rule number is 100, 200, 300, etc. 100, 200, 300, in hundreds actually, etc. The reason is we will have a scope to add rules between 100 and 200. The reason is we will have a scope to put rule between 100 and 200. 100 and 200. See, for example, I am using rule number 1, rule number 2. I want to put a rule between 1 and 2. Is it possible? No. So because of that, they are giving this practice. Even that's what happened, right? When I say add a rule, see what it says 200. That's a basic general best practice. So give it in hundreds, 100, 200, 300, kind of. So it will be easy for us to put the rules between 100 and 200. So that's about your network access control list security group. So one is at instance level, one is at network subnet level. So one is stateful, the other one is stateless. So one there is option to allow deny, the other one there is an option to explicitly say allow deny. That's about your NACLs and security group. So now when it comes to EC2, right? There are three layers of security now. One is the ID password of your EC2. How we log in? By giving some user ID and we give some password. That is one layer of security. What is the second layer of security? Security group. What is the third layer of security? Network access control list. So it provides different layers of security. So that's about your NACLs and security groups. It is designed like that. There is no, I mean, the use in sense, I want to block IP address. Where you go and do it? That's all. That's the only difference there. There are two layers actually. They are providing you a couple of layers. One is at instance level, one is at network level. So based on need, you go and do it at NACL or security group. The design is like that. So accordingly, we need to work. So next one. So we talked about public subnet, private subnet. Correct. So after that, there is a question on this also. See, public subnet is kind of internet facing. All EC2 instances in public subnet gets internet. But what about the instances in private subnet? they won't have internet. Let us say the instances in private subnet, they want internet for different reasons. Like they want to do everyday patching or security updates, whatever it is. They need internet access. So how to give internet access to the instances which are in private subnet? This is again your interview question. Take this point. So giving internet access to the instances in private subnet. Giving internet access to the instances in private subnet. This is asked in the interview. This interview question. We have a couple of ways. Take answer first. Let's see the solution and we'll see how to implement the solution. We can do this in two ways. We can do this in two ways. Number one, using NAT instance, NAT. Using NAT instance. Number two, using NAT gateway. The second one is using NAT gateway. So these two are the options available for us if you want to give internet access to the instances in private subnet. So first let's see how to implement both, then I'll be talking about the differences. So in order to achieve this, I need a VPC, I need a public subnet, I need a private subnet, correct? To test it, I want instances in private subnet, then I need to implement all those things. Let's set up that environment first. So as part of this process, I want to show you the different way of creating a VPC, a different way of creating subnets, private, public, all those things. So we know how to create VPC manually, right? We know how to create subnet manually, how to create routing tables, how to attach, how to make private, how to make public. There is one more option here saying VPC wizard. So this wizard does almost the most of the complexity is taken care by the wizard itself. Take this one. Creating a VPC. Creating a VPC with one public and one private subnet with help of wizard. This is a kind of shortcut. So this is a wizard, right? This is a kind of shortcut. So why I didn't show this in the beginning is the reason we will not understand the basics there. So now you can easily understand what we are doing. So let's go with start VPC wizard. Okay, under VPC dashboard, click start VPC wizard. When I click this, see the options. VPC with a single public subnet. Second one, VPC with the public and private subnets. And the third one, VPC with public, private and hardware VPN access. Last one is with a private subnet, only private subnet with hardware VPN access. Which one we need now? First one or second one? Second one. See that one. See the diagram. This is your Amazon Virtual Private Cloud. We have a public subnet. Forget about NAT. This is what we are going to do. There is a public subnet which has some EC2 instances. We do have private subnet with few EC2 instances. See, after creating this, we are going to use this NAT, which is going to provide internet access to the instances present in private. If you want, you can take this picture. It will be good. Take this one. I'm not sure whether it's going to create a NAT or not, but let's see that one. But at least it creates a VPC with public and private. This is easy, right? Lots of stuff happens by default. What it does, right? It creates a VPC, it creates a subnets, it also creates internet gateways. It will attach internet gateway for your routing table. So everything is done by the wizard, which we did manually the last week. Depends, correct? Some people automate this one. So I want some environment infrastructure. We can automate it. There are different ways to do that. They do it using PowerShell. They do it using cloud formation templates. So if your infrastructure is complex, right? No one takes advantage of doing manually. They always prefer automation. That's where DevOps roles comes into picture. At least AWS has good services, very good services. And I felt it's easy to use. If you understand the core concept, it's easy to use also, user friendly. So I have a plan to give one project where you guys will be implementing the complete CI CD. I will guide you. I will give a project. You should be able to take the project, create a Jenkins jobs, automate continuous integration. From there, automate continuous delivery also. We'll do that using cloud and Jenkins CI2. So highlight cloud AWS. So you'll be having more advantages. Shall I go ahead? See this one. For NAT, there is some early charges. For testing, I can create and I can delete it. That's fine. Let's go with this one. Yeah, obviously, I need to fill in some details, right? VPC with public and private subnets. Cider block range. If you want to change it, you can change it. Let me put a different one. VPC name. Okay, that's fine. What name I should give? I'll put it as QA. One we did for development, right? Let me put it as QA, some name. Yeah, obviously this must be. This is a public subnet. This must be in the same range of. See, whatever range we provide for VPC, correct? The subnets must fall under same range. Otherwise, it won't allow. See, the first section is VPC man. This one. VPC name and side block. The second section is talking about a public subnet. Let me say 1. 10.200 is VPC. Dot 1 is a subnet 1 in that VPC. Availability zone. Put some availability zone and give a name. Let me name it as public subnet itself. The next section is talking about private subnet. Again, the range must be in the same, correct? 10.200.2. Subnet 1 is using 1. Subnet 2 is using 2. So 1 is in 2A. Let me put this in 2B if you want. So public subnet, I'm putting it in one data center. Private subnet, I'm putting it in another data center. If you want to put it in same, those things decided by architects, and so no need to worry about that. So let me call this as a private subnet. Public subnet, I'm calling it as public subnet. Private subnet, I'm calling it as private subnet. But when you're working for a company, make sure why you're creating it, name accordingly. Yes, it also it requires elastic IP. Okay, that is fine. See a couple of options here. What is this? NAT gateway. Why we use NAT gateway? To provide internet access to the private subnets. See the other option. What is the other option there? Use NAT instance. That's what I said. We have two options. One is NAT gateway, the other one is NAT instance. So let us go with NAT gateway now. I will show these things manually again. Let me go with NAT gateway, but I need to have this elastic IP already. What I can do is open one more window, create elastic IP there. Allocate new. Yes, allocate. It's there. It's there. Come back. It's very sad. It opens same one. It wiped off our wizard or what? Maybe ours is gone. Let me freshly do it. So select. So I gave 10.200. Two hundred. 2B public subnet, again private subnet 200. It can be 0 and it can be 1, but remember, first two represents VPC, the next one represents subnet, the next one represents the IP address of your instance in that subnet. So let me put this in 2B. Your name is same. See now, I'm able to see that elastic IP address. Shall I create? What it does now? It creates VPC, it creates private subnet, public subnet, it creates NAT gateway, it modifies the route table accordingly to provide internet access to the private subnet and all those things. Shall I create it? Don't worry, I'll show these things manually tomorrow. Let this work. So meanwhile, so what is this IP address range for VPC, subnet, and for an instance, right? Let's see that one. Not 2434, but at least when I should choose 00 or 1 kind of. See this one. Let's say this is a VPC. Let's say we are giving a range saying 10.200.0.0/16. Okay. Let's say this is a subnet. Let me call it a subnet 1. What should be anyone? What should be the range? 10.200, that is matching your VPC, correct? Dot, let's say 1.0/24. Got it? So 10.200 is for VPC. The next one is for subnet. The next one is for EC2 instance. What's going to be the IP address of EC2? It must begin with 10. It must continue with 200. Correct? It must have the subnet also. What is that? 1. See, 10.200.1, that is matching a subnet. Dot, let's say 45. IP. Got the point? No. That's IP address. IP address. Yes. See 10.200.1.45. That is IP address. See, it is matching your subnet range. The subnet range is matching your VPC range. Who is going to allocate this IP address? It happens dynamically. There is a concept called as DHCP. The allocation of IP address happens dynamically. Whenever I create one more instance, for example, that dynamic allocation happens to EC2 2 also. It makes sure it comes in the same range and it is unique. Can I have one more instance with same IP? No. Those things will not happen, right? Let's say we are creating one more. EC2 instance. What happens? Probably this guy going to get 46. So that's what. So which range you want, that is decided at VPC level. So if you want to start with 192.50, your choice. So if you want to start with 200.10, it's your choice. So that's all for today. So I think that wizard completed. One moment. Yeah, it's successfully created. Let's review this wizard tomorrow, and I'll show how to do the same process manually. Let me